Hello everyone. Today we're going to talk about something super important in Python, the difference between iter and iterators. You've probably heard these terms before, but today we're going to break them down in a way that's easy to understand. So let's imagine you and I are exploring how Python works together. Part 1, Introduction to iter and iterators. Alright, let's dive into the difference between iter and iterators in Python. First, let's talk about iter. So what exactly is iter? Well, it's a built-in Python function that takes an iterable like a list or a string and converts it into an iterator. Imagine you're starting to read a book. Before you start flipping through the pages, you grab a bookmark, something to help you keep track of where you are. That's exactly what iter does. It gives you the bookmark, the iterator, so you can move through the elements in your list or string one at a time in an organized way. Now, why do we use iter? Well, without it, we wouldn't be able to manually move through the elements in something like a list. Python handles it automatically when you use a for loop, but if you want to manually control the process, iter is where it all begins. It's also useful for creating custom iterators when you need more control over how you process the data. On the other hand, an iterator is the actual object that allows you to traverse through the data one element at a time. It has two key methods, underscore underscore iter and underscore underscore next. The underscore underscore iter method just returns the iterator itself, and underscore underscore next is the one that gives you the next element. Going back to the book analogy, think of the iterator as the bookmark. Each time you use next, it's like flipping to the next page. Next moves you through the list or collection one element at a time. And when you reach the end of the book or list, there are no more pages, elements, and the iterator stops. So when do we use iterators? They're perfect for traversing collections, especially large data sets. Instead of loading everything into memory at once, the iterator lets you pull one item at a time, which makes it really memory efficient. You also use iterators when you need custom iteration logic, when you want more control over how the data is processed, or if you want to iterate in a unique way that's different from the standard Python loops. Let's jump into some examples and I'll walk you through them step by step. In this example, we start with a list called my underscore list, which contains three numbers 10, 20, 30. Normally, if you wanted to go through each item in the list, you'd probably use a for loop. But here we're using iter to manually convert the list into an iterator. So when we call my underscore iterator, my underscore list, Python gives us an iterator object. Now, instead of looping over the list, we can use next to manually move through each element. When we do next my underscore iter the first time, it returns the first item 10. The second time it gives us 20, and on the third call we get 30. Each time we call next, the iterator moves forward just like turning pages in a book. But what happens when there are no more items left? That's where the stop iteration exception comes in. Once we've gone through all the elements in the list, calling next again will raise this exception, signaling that we've reached the end of the iterate. In our code, we handle this with a try except block to catch the stop iteration error and print no more items in the iterator. Alright, in the next example, we're creating our own custom iterator class called myIterator. The idea here is to manually control how we iterate through a list. First, we define the class and initialize it with some data, specifically a list of numbers. When we create an instance of myIterator, it stores this list and sets up an index starting at 0, which tracks our position. The class implements two important methods, underscore underscore iter, which tells Python this object can be used as an iterator, and underscore underscore next, which returns the next item in the list each time we call next. If there's a next item, we get it and the index moves forward. But if we reach the end of the list, Python raises a stop iteration exception to let us know there are no more items. As we step through the iterator using next, it gives us 40, then 50, and finally 60. Once we've exhausted all the elements, we handle the stop iteration exception and print that the iterator is finished. This gives us a great hands-on look at how Python manages iteration under the hood. So this example demonstrates how iter converts a list into an iterator and how we can manually step through the list using next, but only until all the items are exhausted. Part 2, Simple differences. Alright, now we're going to dive into the simple differences between iter and iterator, and we'll look at them side by side in a tabular format. This will help us see exactly how these two work together and what makes them different. We'll walk through each aspect one by one and make it super clear. Let's take a look. Definition iter is a built-in function that returns an iterator when you pass it an iterable like a list or a tuple. On the other hand, an iterator is the actual object that enables you to loop through data. It's defined by implementing two special methods underscore underscore iter and underscore underscore next. So you can think of iter as the function that gives you the iterator and the iterator as the tool that helps you walk through the data one item at a time. The purpose of iter is simple. It converts an iterable into an iterator or returns the iterator if the object is already one. For iterators, their role is to allow iteration over a sequence of values one at a time, giving you control to move through the data step by step between the next function. Return value: when you call iter, it returns an iterator object. This iterator doesn't give you the data immediately. Instead, it allows you to fetch the data one item at a time. When you use an iterator, it provides you with the next value in the sequence every time you call underscore underscore next call, making it feel like you're flipping through the pages of a book one at a time. Input: to use iter, you need to give it an iterable such as a list, tuple, or even a callable with a sentinel value. This tells Python what data to convert into an iterator. In contrast, an iterator itself doesn't take a input when you're using it. It's the object that iter returns, ready to give you the next element whenever you call next. Method used for iteration: here's a key difference. Iter doesn't actually do the iteration itself, it just gives you the iterator. The real action happens with the iterator, which uses the underscore underscore next method to return elements one by one. In short, iter sets things up and the iterator does the actual work of moving through the data. Common usage: you commonly use iter when you want to obtain an iterator from an iterable. This lets you look through the bean structures like lists, tuples, or strings. On the flip side, iterators are used to actually retrieve each element from the collection, whether it's in a for loop or manually using next. Raises exception: one important difference is that iter does not raise any exceptions when creating an iterator from an iterable, as long as the object is iterable. However, when you're working with an iterator, it will raise a stop iteration exception when it has exhausted all the elements. This is how Python knows that it's reached the end of the sequence. Part 3: hands-on examples for simple differences. In this example, we're exploring how to use the iter function to convert a list into an iterator, and then how to use the next function to manually step through the elements of that list. We start by defining a simple list called my underscore list with 4 elements: 1, 2, 3, 4. Normally, when you loop through a list using a for loop, Python automatically handles the iteration for you. However, in this case, we manually create an iterator from the list by calling the iter function my underscore iterator my underscore list. Once we have the iterator my underscore iter, we can use next to retrieve the elements one by one. Each time we call next my underscore iter, the iterator gives us the next item from the list. The first call returns 1, the second call returns 2, the third call returns 3, the fourth call returns 4. In the next example, we create a custom iterator class called counter that generates numbers between a given start and end value. The class has two important methods: underscore underscore iter, which simply returns the iterator object itself, and underscore underscore next, which returns the next value in the sequence. When we call underscore underscore next, it checks whether the current value exceeds the end value. If it does, the method raises a stop iteration exception to signal that the iteration is complete. If not, it returns the current value and increments it for the next call. For example, when we create a counter instance with a start of 1 and an end of 5, each call to next returns the numbers 1 through 5. After the fifth number, calling next again raises the stop iteration exception, ending the iteration. This approach gives us a custom controlled iteration behavior similar to Python's built-in iterators. Part 4: advanced and complex differences. Now, let's dive into the complex differences between iter and iterators. We've already explored the basics, but there's more to these concepts than meets the eye. These differences will help you understand the deeper mechanics of iteration in Python, especially when dealing with custom iterators, memory efficiency, and advanced use cases like lazy evaluation. So let's go through each point and break down how iter and iterators operate differently in more advanced scenarios. Primary function: the primary role of iter is to return an iterator when passed an iterable like a list or a tuple. If you pass an iterator itself to iter, it simply returns the same iterator. It's like setting up the process for iteration to begin. on the other hand. An iterator is an object that does the actual work of returning elements one at a time when you call next. It manages the sequence and gives you the next item until it's exhausted. How it's defined. Iter is a built-in function that triggers the underscore underscore iter method of an object to get its iterator. This means that any object that implements underscore 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 iter can be turned into an iterator. Side, an iterator is an object that implements both underscore underscore iter to return itself and underscore underscore next to provide the next element in the sequence. Together, these methods allow the iterator to work within Python's iteration system. The relationship between iter and an iterator is like preparing and acting. Iter is used to get an iterator from an iterable. Without iter, you can't manually iterate over something like a list. Once you have an iterator, you can start pulling out items one by one using underscore underscore next, which is what makes the iterator essential for manual iteration. State management, while iter doesn't manage the state directly, is the function that initializes the iteration process. The returned iterator is the one that tracks the state, like which item in the list comes next. And iterator keeps track of where it is in the sequence and resists stop iteration when it's done, signaling that there are no more elements to return. Custom object creation iter is primarily used to convert an iterable like a list or tuple into an iterator. It's the easy tool to get things going. For more advanced scenarios, iterators themselves can be customized by implementing the underscore underscore iter and underscore underscore next methods in a class. This gives you full control over how elements are returned and when iteration ends. Reusability without you can call it multiple times on the same iterable to get a new iterator each time. Each new iterator starts from the beginning of the sequence. However, once an iterator is exhausted, once it has iterated through all elements, it cannot be reused. You'll need to call iter again on the original iterable to start over with a new iterator. Error handling: when you use iter, it doesn't raise any errors unless the object you pass isn't iterable. In contrast, an iterator raises a stop iteration exception when there are no more items to return. This signals the end of the iteration process, which is something Python uses internally to stop loops. Infinite iterators: you can use iter with a callable and sentinel value to create infinite iterators, like when you want something to repeat until a condition is met, e.g. iter callable sentinel. On the other hand, custom iterators can also be designed to implement infinite sequences, but you have to be careful not to end up in an infinite loop. Custom iterator creation iter is used to call the underscore underscore iter method of an object and get its iterator. When you're creating custom iterators, you define both underscore underscore iter and underscore underscore next methods in a class to specify how iteration should happen. This allows you to customize the iteration behavior completely. Used with generator functions, you can call iter on a generator function to convert it into an iterator. This is useful because generators automatically support iteration through their underscore underscore next method. Since generators are inherently iterators, you don't need to do much to use them in a loop. Multiple iterators. Each call to iter on the same iterable creates a new iterator that starts from the beginning. This means you can iterate over the same data multiple times by calling iter again. But once an iterator is exhausted, it cannot be used. You'll need to create a new iterator if you want to start over. Relation to lazy evaluation iter can be used with objects that support lazy evaluation, such as reading lines from a file, instead of loading everything into memory at once. It generates elements only when requested. Similarly, iterators also enable lazy evaluation, making them efficient for handling large datasets because they generate items on demand. Bidirectional traversal iter always returns a forward-only iterator, meaning you can only move forward through the items. If you want to traverse in reverse or move both directions, you'd have to implement a custom bidirectional iterator. Using custom classes: in custom classes, you can implement underscore underscore iter to allow the class to return an iterator when iter is called. On the other hand, a custom iterator class must implement underscore underscore next to specify how the iteration works, making it possible to define exactly how and when elements are returned. Chaining iterators: you can use iter to chain or nest iterators by calling it on an existing iterator. This allows you to combine multiple iterators together, making it easy to loop through them sequentially. Iterators created by chaining simply pass through the results of the underlying iterators. Callable and Sentinel form iter has a special form where you can pass a callable object and a Sentinel value, and it will keep calling the function until the Sentinel is returned. This is useful when you want to create an iterator that keeps going until a certain condition is met. The iterator created this. We will invoke the callable repeatedly until the Sentinel value is reached. Performance considerations using iter is generally efficient, especially when dealing with large datasets because it doesn't load everything into memory at once. Similarly, iterators are also memory efficient since they generate values on demand, which makes them ideal for processing large collections or streams of data one element at a time. Part 5 hands-on examples for complex differences. Example 1 using iter with callable and sentinel. In this example, we are using a special form of the iter function that works with a callable function and a sentinel value. The idea is that iter will keep calling the provided function until the function returns a specific value known as the sentinel, at which point the iteration will stop. Here we define a function called countdown that prints starting countdown and always returns the value 10. Then we create an iterator using iter countdown 5, which means the iterator will keep calling countdown until it returns the value 5. Since our function always returns 10 and never reaches 5, the iteration continues indefinitely. In the for loop, every time the iterator calls countdown, it prints the message and returns 10. This keeps happening because the function never returns the sentinel value of 5. The loop would go on forever unless stopped manually, demonstrating how iter can be used to repeatedly call a function until a specified condition is met. Example 2, demonstrating lazy evaluation with iterators. In this example, we're demonstrating lazy evaluation using Python's range function and iter to handle large dataset without loading everything into memory at once. First, we create a large range object called large underscore range that spans from 1 to 1 million. Even though this range is huge, Python's range function is memory efficient because it doesn't generate all the numbers at once, it only produces them as needed. Next, we convert the large underscore range into an iterator using iter, which allows us to manually retrieve elements one at a time using next. This is where lazy loading comes in. Instead of loading all 1 million elements into memory upfront, the iterator generates each element only when requested. When we call next large underscore iter, the iterator returns the first element 1, then the second element 2, and continues to provide elements as we ask for them. This is much more efficient for large datasets since only the needed elements are computed and returned. Finally, we use a for loop to retrieve and print the next 3 elements. By using lazy evaluation, we can iterate over large datasets without overloading memory, making this approach particularly useful when working with massive collections of data. Example 3, bidirectional iterator. In this example, we create a custom bidirectional iterator that allows us to move both forward and backward through a list of data. Normally, Python iterators only allow you to move forward, but this custom class adds the ability to go back as well. We begin by defining the bidirectional iterator class, which takes a list of data as input and initializes the index to -1. The underscore underscore iter method simply returns the iterator itself, which is necessary to make the class iterable. The underscore underscore next method is responsible for moving forward through the list. Each time we call next, the index is increased by 1 and the corresponding element in the list is returned. If the index exceeds the length of the list, the stop iteration exception is raised, signaling that there are no more elements to return. What makes this iterator special is the pre method, which allows us to move backwards through the list. When prev is called, the index is decreased by 1 and the previous element is returned. If we attempt to go back before the start of the list, i.e., when the index is less than 0, the method raises stop iteration to prevent further backward movement. In the execution, we create an instance of the bidirectional iterator with the list 10, 20, 30, 40. We first use next to move forward and retrieve 10 and 20. Then by calling prev, we move back one step and retrieve 10 again. This custom iterator provides a flexible way to navigate through a sequence in both directions, which is not typically possible with Python's default iterators. Example for chaining iterators with iter. In this example, we use the iterators.chain function to combine multiple iterators into a single iterator, allowing us to iterate over two lists as if they were one continuous sequence. We start with two separate lists, list 1 containing 1, 2, 3 and list 2 containing 4, 5, 6. Normally, these two lists would have to be iterated over separately, but with chain, we can treat them as one unified sequence. First, we convert both lists into iterators using iter, which allows us to step through each list element by element. Then we pass these iterators to chain, which creates a new iterator that first pulls elements from list 1 and once it's exhausted moves on to list 2. This way, the elements from both lists are chained together in a seamless manner. Finally, we use a for loop to iterate through the chain underscore iter. As we iterate, the loop first yields the elements from list 1, 1, 2, 3, and then moves on to list 2 to yield the remaining elements 4, 5, 6. This allows us to iterate over both lists as if they were one without needing to manually combine or concatenate them. This approach is especially useful when dealing with multiple collections as it allows you to iterate over them in sequence without merging them into a single list, saving memory and processing time. That's it for today's video. I hope this walkthrough of iter and iterators has cleared up any confusion you might have had about how they work. These concepts are really powerful once you understand them, and they're essential for writing efficient Python code, especially when you're dealing with large datasets or working on complex projects. If you found this video helpful, don't forget to hit the like button and subscribe for more Python tips, tricks, and tutorials. Also, if you have any questions or suggestions for future videos, drop them in the comments below. I'd love to hear from you. Thanks for watching and happy coding.